Good morning, friends. I'm SJ Edwin from BSc Physics first year. Now I'm going to take a seminar based on the topic derivation of gas equation of state, internal energy and pressure for monoatomic ideal gas from kinetic theory of gas. First, we are going to see about what is internal energy. Internal energy in real gas and internal energy in ideal gas. So first, what is internal energy? Definition of internal energy. Internal energy is the energy content of a system. This is defined as energy content of a system is called as internal energy. So we are going to compare internal energy in both gases, that is in ideal gases as well as in real gas. So internal energy in ideal gas and real gas. Internal energy in ideal gas is only dependent upon temperature. For internal energy in ideal gas is only dependent upon temperature, and internal energy in real gas is dependent upon both temperature and volume. So what is the difference between internal energy in ideal gas and internal energy in real gas? So we are going to discuss about that. Internal energy in real gas, for a perfect gas, for a real gas, it is obeying van der Waals equation. Real gas obeys van der Waals equation, and the internal energy is the sum and potential energies of molecules due to the mutual forces of attraction. So for real gas, it has mutual forces of attraction and it has intermolecular distance and it obeys van der Waals equation. Therefore, the real gas has dependent upon both temperature and volume. Now, as we have discussed about that, here we see the diagram where potential energy is equal to kinetic energy is equal to internal energy. How this diagram is formed? The internal energy of a system is the energy contained within the system, and it is excluding the kinetic energy, and that potential energy of the system is whole due to extra field. So kinetic energy is excluded here. So potential energy plus kinetic energy gives internal energy. Now next we are going to see about monoatomic ideal gas. So what is monoatomic ideal gas? We have seen monoatomic ideal gas in both many subjects as physics, chemistry, biology. Now in physics, monoatomic is a combination of words. Mono and atomic. Mono is a single, atomic is an atom. So monoatomic is usually applied to gases, and monoatomic is one in which atoms are not bounded to each other. So in monoatomic gas, atoms are not bounded to each other. Next, it is extremely simple when compared to other gases. Example, polymorphic gases, and it is vibrational energy. So altogether we can say it is an extremely simple gas. Next we are going to derive equation of state. Yes. I have derived using different thing, that is law. So according to Boyle's law, at constant temperature T, pressure P is inversely proportional to volume. That's Boyle's law. And according to Charles' law, at constant temperature, at constant pressure, the P and the volume V of a given mass is directly proportional to temperature. And according to Avogadro's law, equal volumes of all gases under the same condition of temperature and pressure contain equal number of molecules. So by these three laws, we calculate V is equal to I by P, V is equal to T, and V is equal to N by three: Boyle's law, Charles' law, and Avogadro's law. So by deriving, V is directly proportional to I by P into temperature into Avogadro's law, that is number of molecules, N. So by that P, if we multiply P above PV is directly proportional to Tn. So by substituting R as gas constant, we get PV is equal to RT. Thus, we found out the equation of gas constant as PV